review measures of variability. In this video, we'll review how to compute range, variance, and standard deviation. Now, measures of variability are a single value that describes how spread out our data is, and this value helps us understand how clustered or how dispersed our data is. So the smaller the value, we understand that as being more clustered, less variability, and then the larger the value, more spread out, more dispersed, the higher the variability. So the measure of variability really helps us understand the spread of our data. The three measures are range, variance, and standard deviation. Now, the range is the simplest form of variability. We're just taking the highest score minus the lowest score, and that gives us the range. Typically, we're using the range when we're describing something about our participants, like age range or income range. That's typically where you would see it. Variance is the average squared distance from the mean. We don't typically report that. Actually, we use variance in other formulas that we'll focus on in another topic down the road. And it's along the way to computing standard deviation. Now, standard deviation is an important value that we often see reported with the sample mean. So it helps us understand the center with the mean, and then the standard deviation is reported with it so that we understand the variance or the spread of our data. And standard deviation is the average distance a value is away from the mean. Now, variance and standard deviation, how we compute it, we already know is a little bit more has a little bit more detail than one statement, but we'll go through that, a review of that in a few moments to go through how do we compute variance and standard deviation. Okay, so we're going to use the same recent quiz scores that we did for our measures of central tendency to show how we can compute first the range. So we're looking at the range is the maximum or the highest score minus the minimum or the lowest score. And typically we want to put our scores in order to identify what is the maximum and the minimum. We could do it in descending order or ascending order, but we have it in order by lowest to highest in this case. So we can see in this case we have 10 is our highest score and 5 is our lowest score, so it's 10 minus 5, and our range in this case is 5. So that's the range. Now we're going to compute variance and standard deviation for these quiz scores, and we can do them sort of not at the same time, but before we even get to computing variance and standard deviation, we know that we need to complete the sum of squares table. So the sum of squares table, as a reminder, we have our participant identifier, so we're using numbers in this case. We have our quiz scores. At the bottom, we're computing our mean of quiz scores. Then we're getting each score's difference or distance from the mean, so that's our quiz score minus the mean. Then we do that for each participant. We sum that should be 0, and then we square our deviations, and then we sum those square deviations. So let's go through that process. So we've already computed the mean in a previous video, so we don't need to do that. And so the mean in this case was 8. So we'll put in 8. That's our mean of our scores. So we're just adding those up divided by 6. We did that in a previous video. So now we're going to take 10 minus 8, which is 2. So we're taking each score's deviation. 5 minus 8, which is negative 3. 8 minus 8, which is 0. 10 minus 8, which again is 2. 6 minus 8, which is negative 2. 9 minus 8, which is 1. And then when we add 2 plus negative 3 plus 0 plus 2 plus negative 2 plus 1 is 0. And this should always be the case. Our deviations, because we're looking at the distance of each score from the mean, should always be 0. Okay, so once we have our deviations, we're going to square. So we're going to square our deviation for our participant number 1. So 2 squared is 4. Negative 3 squared is 9. 0 squared is 0. 2 squared is 4. Negative 2 squared is 4. 1 squared is 1, and then we're going to add these up. So 4 plus 9 plus 0 plus 2, 4 plus 9 plus 0 plus 4 plus 4 plus 1 is 22. So that's our sum of squares. And we can see that the sum of squares is in the numerator for both variance and standard deviation. So we're going to put 22 into the numerator. This is going to be the square root of 22. Oops. Okay, and then in the denominator, we're putting our degrees of freedom. And degrees of freedom is computed by taking n, which is our sample size, minus 1. So in this case, we have 6 participants, so we know that because we have 6 participants, minus 1 equals 5. So 5 goes in the denominator here, so it's 22 divided by 5, and square root of 22 divided by 5. So what that ends up being for our variance is 4.40 is our variance, which is just the square distance from the mean, which doesn't really give us a whole lot of intuitive information. But when we take the square root of our sum of squares divided by our degrees of freedom, which is essentially variance, we get 2 point and then a bunch of digits after that. We're going to round it to 2.10. 2.10, if we think about this, say that we were told that this quiz only had 10 points. Okay, so the maximum score you could get on this quiz was 10 points. If that's the case, the range of our points is 0 to 10. 2.10 is kind of a large distance or difference. It's kind of spread out if we are only looking at a high score of 10. So putting it into context is also important. Just saying that 2.10, just like relatively, is a small value. But in the context of only having a quiz from 0 to 10 points, right, if that's what we're told, we're going to say that's pretty high variance, where 2-point difference from the mean is pretty large considering how the range. Okay, so that's just a little aside there, but that's how we go through computing our range, variance, and standard deviation for our quiz scores. So in the next video, we're going to talk about how to put all these values together, because it's not about computing values, it's about how to make sense of those values.